Our solar system holds a world of possibilities. Among them is Venus, often called Earth's twin. It's similar in size and mass to our planet. However, Venus is a scorching inferno, shrouded in thick clouds. But what if we could change that? Imagine transforming it into a second Earth. This is the dream of terraforming. Imagine a vast array of mirrors, strategically positioned in orbit around Venus. These mirrors would reflect a significant portion of sunlight away from the planet. This would have a dramatic cooling effect. Over time, Venus's surface temperature would begin to drop. The thick atmosphere would slowly cool. It would be a gradual process requiring careful monitoring. Constant adjustments would be needed to find the balance. As Venus cools, its dense carbon dioxide atmosphere would begin to change. Carbon dioxide, the primary culprit behind Venus's extreme heat, would start to condense. Instead of a thick, gaseous blanket, it would transform into something more manageable. This transformation is crucial for creating a more Earth-like environment. However, completely eliminating Venus's atmosphere is not the goal. We need an atmosphere, just not one as dense or as hot. This is where the strategic manipulation of our orbital mirrors comes into play. By adjusting their angle and position, we can control the amount of sunlight reaching Venus. This allows us to fine-tune the planet's temperature, creating a temperate climate suitable for life. Venus rotates incredibly slowly, resulting in a day longer than its year. This quirk of celestial mechanics presents a challenge for terraforming. Earth's life is accustomed to a 24-hour day-night cycle. To create a familiar rhythm on Venus, we can once again employ our orbital mirrors. By carefully angling these mirrors, we can simulate a 24-hour day-night cycle. Specific areas of Venus would be illuminated, while others are cast in shadow, mimicking the familiar pattern of day and night on Earth. This manipulation of light and shadow would be crucial for establishing familiar biological rhythms for any life we hope to establish on our newly temperate twin. Section 5. Magnetic Mastery, shielding Venus from the Sun. Venus lacks a substantial global magnetic field, leaving it vulnerable to the solar wind. This constant barrage of charged particles from the Sun poses a threat to any potential atmosphere and life we might establish. To protect our terraformed Venus, we must find a way to deflect these harmful solar particles. One solution lies in harnessing the power of electromagnetism. By strategically positioning a network of conductive coils around Venus, we can generate an artificial magnetic field. These coils, powered by solar energy, would create a protective barrier around the planet, deflecting the solar wind and safeguarding the developing atmosphere and any life below. Section 6. Breathing life into Venus, from CO2 to breathable air. With a more temperate climate and a protective magnetic shield in place, we can turn our attention to transforming Venus's atmosphere. The dense carbon dioxide, while diminished, still presents a challenge. We need to convert this CO2 into something breathable, something that can sustain life as we know it. This is where advanced technology comes into play. By deploying massive, specialized machines on the Venusian surface, we can begin the process of atmospheric conversion. These machines would use a combination of electrolysis and chemical reactions to break down carbon dioxide, releasing oxygen into the atmosphere and sequestering carbon. Section 7. Bringing Earth to Venus, a planetary relocation. With a more Earth-like atmosphere, the next step is to seed Venus with life. This involves carefully selecting and transporting a diverse range of organisms from Earth. These organisms, ranging from microscopic bacteria to hardy plant life, would play a vital role in establishing a functioning biosphere on our neighboring planet. This transplantation wouldn't be a haphazard process. We would start with bioengineered organisms capable of thriving in Venus's unique conditions. As the planet's ecosystem matures, we can introduce more complex life forms, gradually creating a vibrant and diverse biosphere capable of supporting a wide array of life, including, eventually, humans. Section 8. A garden paradise food forests on Venus. Imagine a Venus covered in lush, vibrant food forests. These ecosystems would provide sustenance and shelter for the Venusian population. Imagine fruit-bearing trees reaching for the sky, laden with exotic fruits. These forests would be more than just a source of food. They would regulate the climate, prevent soil erosion, and provide habitats. This approach ensures the sustainability and habitability of our new Venusian home.